This diagram illustrates ejection fraction, and the reason for this is because it's so heavily tested, not only on medical school tests, but also on boards. So the ejection fraction, and this is a flow volume loop, as you can probably tell, is literally just this. Ejection fraction equals the stroke volume divided by the end-diastolic volume. And so if you remember, here's our end-diastolic volume right here, and that's 100%. If you think about it, going from this being 0 right here all the way to end-diastolic volume, that's as much blood as going to go into the left ventricle. So remember, we're always talking about the left ventricle. And so what's going to happen is we fill the left ventricle to end diastolic volume, we go up, have our isovolumic contraction, then we have our ejection, then we have our, do you remember, peak isovolumic pressure, okay, and then we have our isovolumic relaxation, and this here, isovolumic, the volume hasn't changed, this would be our, what, end systolic volume, end systolic volume, and look, I put in a little test here to see if you could catch me, and I wrote end diastolic volume, so I'm going to need to change that, but that was actually a test, I think. So anyway, so what you want to do next is you want to just take your stroke volume. So where's your stroke volume? It's the distance from here to here. Okay, that's your stroke volume. So stroke volume, if we wanted to write an equation for it, stroke volume equals end diastolic volume minus end systolic volume. And or you could even say beginning diastolic volume or something like that. So anyway, so there's some arrows here just to kind of illustrate that. So here would be the total. This would be 100% of what's going to go into the left ventricle, which is represented by this circle here. And then this would be the left ventricle after the blood's been ejected. And so the stroke volume, which is represented right here, which is going to be the same distance as right here, you take this and divide it by the end diastolic volume, and that'll give you your ejection fraction. And that's a really important calculation for clinical medicine. It'll be on your board exam, and it'll probably be on your medical school test.